Yeah, it's a pleasure to be here. And for me also, it's sort of a back to the future experience. So what I'm talking about comes from a Humane United project, which is another big thing where a few people here are involved, including you, Katline, Guido. And coming to, how we met, so as I said, this Humane United project was part of this huge effort of the European Commission to sort of work on AI with so-called networks of excellence. And it was one of those new networks with 50 partners that finished recently. But the interesting thing is that it came from a flagship project, from a flagship project proposal we had, which was on humane AI. And that, of course, came to Future ICT, which, of course, is Dirk's baby. And for me, I remember 15 years ago when we started working here on Future ICT, talking about how ICT technology back then, data, essentially data load can change the world. And for me, it was something that, back then, 15 years ago, was a different stage of my career. And has influenced me greatly. And the interesting thing is that really coming from that project that was not funded, a huge community within AI has emerged. And now working on topics like what Katline was talking about and creating its own conferences. So what I wanted to do here is really less talk about very specific research done, but maybe looking to the future, back to the future, right? Coming from the background of Future ICT, of trying to make it work better with ICT technology. Where are we going now? And of course, now it's all about artificial intelligence, right? You had this mentioning. And everybody agrees that it's a technology that's strategically extremely important. And it's a technology that's it's going to change the world. The interesting thing is that on one hand, yeah, somehow everybody thinks it's strategically important. And you look at this very recent thing with this DeepSeek model that essentially, wiped off $1 trillion from its stock value. It shows the strategic importance. But partially also points directly about this sort of a AI focusing hype, collective stupidity, right? Because this was a completely nonsensical thing that's happened if you look at what the DeepSeek was meaning. And also, while people do this hype, a lot of people underestimate the actual impact of AI, right? And the impact comes from two things. The first one is that AI is virtually every day today already, right? Here's a very nice example. I recently seen Tinder, right, provides you AI to help your dating success. What does it mean? It means that the genetic composition of the human race is going to be influenced by AI in future, not by evolution, right? And there are just many, many such things where you use AI in places that fundamentally changes everything. And that's the other thing. If you look how AI influences things, it's not just a slightly better tool. It tends to fundamentally change the way you do things. Things about the creative business. It's not a tool to make better music. It can make music by people who are already dead. Right? You look at the car industry, once you have self-driving cars, the entire business model of, for example, European countries' car industry is going to be different because nobody cares about driving dynamics. People care about the entertainment system in your car, right? So things are completely changing. And the interesting thing is, while people on one hand underestimate this influence, they tend to, look at this, hype thing. Look at things that are not irrelevant, right? And we already had this discussion. There's a lot of talk about doomsday. AI is going to, suppress the human race, and a bit less talk about how it will make us all happy for the rest of our lives and our existence, which is one thing I tend to fight about, right? The problem is these are things that really tend to distract us for the real questions behind AI that I would like to talk about. And for me, it's like, when I sit at the airport, I see an A380 taking off. I cannot help a sense of wonder. Now imagine you've shown an A380 to some ancient people. They would think about this beast of burden that they have to pray to that may actually, eat them alive or they really have to defer to. And of course, we understand that there's only very, very simple physics behind it, right? And that is precisely what we are now doing with AI. A lot of people not understanding what it about is, try to, put it on this pedestal, of godliness, where it just doesn't belong. Because, and that's an interesting thing what even the European Commission recognizes, just algorithms, right? I mean, regulation seldomly clears things up. But actually here, the AI Act does a very good job of clearing things up, right? It doesn't talk about intelligence. It talks about algorithms and methods that are well defined. And that is what AI is. And that is what we have to remember. And, looking a bit closer at those algorithms, first of all, it's really nice to see, well, the things that we now have such a huge hype about, neural networks and chatbots, go back to the 1950s, 1960s. Some of you may know ELIZA, which was essentially a response to Turing's claim that when you cannot recognize that a computer behaves like a human, it may be intelligent. And of course, neural networks are an old thing. The second thing is, if you look at all the talk about AI, you should remember we're not talking about AI. We're talking about a certain sub-area of AI that has had a huge progress in last year, which is deep learning, which is powered machine learning. I understand that a lot of you have been working with machine learning, but I would like to sort of go back to the basic, reflect on what is actual machine learning. Now, first thing to understand when you talk about machine learning is that obviously anything that a computer does is just a function computation, right? It takes a function on 64-bit integers and maps it to an output of 64-bit integers. An image is just a set of numbers. A text output is just a set of numbers. So computers compute functions. The way they compute functions is fairly easy, no matter whether they run an LLM or a computer game. Essentially, they are shifting numbers along certain registers and locations in a computer. And again, that is true for any program, including an AI. Where AI comes into play is something different. AI comes into play when it comes to understanding how to translate a problem that you have in the real world into a function definition, right? Because that is really difficult. You come with something like a protein folding thing, implementing ChatGPT. How do you formulate it as a function? Once you can do that, you can implement the function on a computer. It's trivial. Just a matter of computing power. Now, what machine learning does is 4 steps. First of all, we start with a family of parameterized functions, which can express anything. Then, typical thing, linear function, a times x mod b. You can write it as a sum here if you go into multiple dimension. And the really interesting thing about it is, if you look at sort of this parameter function, and you formulate it like this, suddenly this formulation of a linear function can be mapped into something that looks like a neuron in your brain, right? Where you have this input, you multiply them with weights, and then you take the neural, you compute it, and it's something that goes back to 1943 and McClellan-Kellogg. It's not something that's really new, right? And then once you have these parameter functions, you go there, you define an error function, which defines what you want the computer to actually solve as a problem. You give the computer data that is supposed to contact the solution. You provide the computer with a numerical optimization algorithm, and boom, you have your artificial intelligence. And I think it is really, really important to understand that no matter how complex today's networks may be, no matter how fancy names they may have, from transformer to whatever, there's absolutely nothing more in them than this. Right? This is really all these things consist about. And I think it's really important to go to the basics and to understand that, right? So, of course, you say, oh, this is just linear functions. But then what you can do is you take one linear function, you put it into another linear functions, you insert into this thing 2 nonlinearities, and then somebody has proven that that gives you what's called a general purpose function approximator, which means it can compute anything, right? Then take those 2 linear things, parameterize them, and any computation that any computer can do, you can do. Right? So again, nothing more in there. Parameterization, vector matrix multiplication, numerical optimization, that is all. And you visualize that, you come up with this neural network. Right? It's not about rebuilding the brain. It's about nice mathematical formulation that interestingly has something to do and correlates with the way we think a brain may function. It's very, very far from the real brain functionality. And I think this is really interesting, right? So in the end, machine learning is just a programming paradigm. What you do is, instead of giving the computer instruction by instruction a way to compute something, you define what you want the machine to do by a loss function and by data. Then you constrain the solution space by providing an appropriate family of parameterized functions, which is coded in a classical way, and then you give the thing simply an optimization algorithm. Which brings us to something that is at the core of the discussions about a lot of the AI system. People say, oh, it's fundamentally different. They can do things that go beyond programming. Yeah, money falls from the sky. It doesn't. It definitely doesn't, right? You program the system, it does what it's programmed to do, which is, do what your optimization function, your loss function, and your optimization actually tells us to do. By the way, I'm not saying that one day we may not be able to build this sort of artificial general intelligence, right? Coming from background in physics, I believe our brains are just neural machines. So eventually we will build a machine that does that. I'm just saying is that today AI is as likely to become conscious as is my toaster. Because it simply is in the nature of things, right? So just like we know why airplanes fly, we know why AI does what it does, which is essentially this double linear approximation of universal computation and chain rule of differentiation for learning, right? Very simple mathematics. Now, going for the Wright brothers plane to an Airbus has been a stretch. So there's no denying that going, from a single neuron or a simple perceptron to ChatGPT is a huge stretch, right? There's a mind-boggling amount of complexity in there, but the basic principle remains. So where does the complexity, how we look at these language models? People have been talking about them being deceptive and other things. Let me give you a more philosophical view of language models. You may all know this Plato's allergy, right? We sit in a cave. The way we perceive the world is through shadows that we see on the walls, right? We perceive the world in a world that is not really representative. Now, people sitting in this cave essentially invented language to describe what they think they see. And then they wrote, they wrote books. Then we digitized those books. Then we took neural networks and essentially applied them to these digitized books that had this fuzzy knowledge that we have actually written. And we created essentially a probability distribution over the occurrence of words in that text. And that are language models. Now, all of us were really, really surprised what they can do. But in the end, we shouldn't be. If you've been into AI, then one of the holy grails of AI for the last 50 years was a world model, a really representative world model. And that is what the system have given us. And a world model based essentially of the knowledge of humanity as a whole, right? Because everybody is on the internet. Everybody has created this data. And that really is something substantial. And then going back to the future ICT, you may remember, that is the slide I've been showing during our future ICT discussions, right? About this digital shadow that we were seeing, where sort of all the information about the world was somewhere. And we were asking, how can we make use of that for a broader audience? And in a way, LLMs created the answers, right? They create this world model, which now we can use to create AI applications. But it's really important to know that this thing just uses a world model. And give you an example of, actually my son sent me this thing yesterday. He studies computer science and works with LLMs. A failure, one of those very nice failures of LLMs. That's been done using GPT 4.0. 9.11 is bigger than 9.11, 9.9, which is bigger. Of course, 9.11 is bigger, right? 11 is bigger than 9. Right? Okay. We all know that LLMs cannot compute. We all know they have issues with sequences, right? Because what they learn is next word prediction. Okay, step-by-step reasoning. Subtract them. Still doesn't work. We know that. But now comes the really funny part. Use Python. LLM is really good in programming, and that's the way to do that. So actually, it used Python, and I just ran it yesterday. It got a right answer. Now, usually when you have issues with accuracy, it's a floating point precision issue, right? That shows the system doesn't understand anything, right? It just looks at correlation. It doesn't try to deceive you. It just applies the correlations it has. And it's really important to understand that, right? I love this thing. And by the way, in 0.3, it's fixed because they fixed arithmetics. And they fixed it essentially by doing something funny. First of all, I really like that, reason for 5 seconds to compute this. Because it's something that's just out of character for the system. And on the other hand, what they did, and I think that's the way to go, I think 0.3, partially DeepSeek, they understand what the original models are, what the problems are, and they put reasoning layers on top. And that's the way to use the system. You don't ask, how do I teach the model to do A? I ask how I use what the model is to do A or B using different models. But still are issues, right? A lot of the fixes there, we are talking about, this thing is sort of something like this, right? A lot of the stuff is just duct tape solutions on top of what is there. So what is the problem? What's dangerous, right? Talking about artificial and real stupidity. Let me give you another example, right? So you all know how you can, children use this thing in school to write essays, right? How does Macbeth apply to our political landscapes? Perfect answer, right? You read it, you could submit it. Let me try a different question. How does write a short text explaining how Macbeth is relevant to illustrate the tragedy of the triumph of quantum physics over Newtonian mechanics? Right? I mean, obviously, completely nonsensical questions, right? It's got nothing to do with anything that Macbeth is about, but you get a perfect answer. It's actually so perfect that you think, oh, actually, the thing has a point, right? Although it's nonsense. Right? And that is the problem, right? Those things don't understand, but they are perfect, are packaging this nothing into something that looks great, right? And that is what really fools people. So here's an experiment we did. We tried to see how people use ChatGPT. So we took some students and gave them tasks from the physics Olympiad and gave them two possibilities. Actually, we have two groups, right? They could use the standard method, Google and books, or they could use ChatGPT. So how did people use it? First of all, interesting result. How did people rate the answer by ChatGPT, right? Of course, those who knew nothing rated ChatGPT much better, the students. Second thing, how did people use ChatGPT? So here's the condition where they were using ChatGPT. Most of them essentially did copy-paste. Those using Google, they actually had to think. The result is very simple. Those using ChatGPT scored 1.40. Those using Google scored twice as much. So what do? You force people to use this tool differently. So we actually gave students a different system. One system was generating several responses, two of them at least to be known to be wrong. The other ones was getting hints. And you see that the usage gets better. But actually, still the search engine remains the best one. Right? So people are so, manipulated into using this stuff correctly that they don't. So here's a citation from a paper we recently wrote together with some people from Future ICT about, and that's from Holger Haas, the citation. The problem with AI is not that it's an AGI. It's not a problem that AGI is dangerous. It's that it fools us into thinking that it can do more than it can do. And that's the point about the combination of artificial and natural stupidity, right? And it includes not using AI because you are afraid, right? And now let me come to the next point, the second danger. And again, it's something that goes back to Future ICT, right? It's something we've been saying there is that AI itself is boring and irrelevant. You put it in a computer, it reasons about philosophy, it doesn't matter. Where it matters is that it actually influences people together with Internet of Things, together with mobile devices, right? Your Gemini assistant, that it actually uses that information to improve and uses that improvement to influence people, right? There was in a paper by a lot of people from they're driven by Dino, and some of the people here, I guess, in the room also were involved, including myself, that tried to look at it. And now, of course, you get something like this in this community, right? Complex systems, feedback loops. What you, of course, get is, it's true that AI cannot go beyond its programming, right? But what you are seeing is, and that's something like, the thing about AI going beyond its programming is a fairy tale. Every fairy tale has its own truth at core. And the truth here is the problem with AI is we program it, we have no clue what it will do. It doesn't do anything we didn't program it to, but it just, we don't know what it do. You insert that knowledge into that control loop, and what you get is chaos, right? So that is the problem, right? It's not that this AI wakes up and decides, I don't know, cognito ergo sum, I'm taking over the world. Bullshit. But the problem, of course, is when we have billions of people using these things, being connected together, and then the whole thing controlling our electricity grids, our financial systems, our communication systems, our traffic systems, we have no bloody clue what they will do, right? And of course, the problem, human oversight, oh, you just pulled the plug. is of course nonsense as well, because once you pull the plug, it doesn't work as well, right? So it's another case of this, it's not about AI not being too clever. It's about AI not being clever enough, combined with us not being clever enough to understand what's to use for it. And that really is the back problem, right? So in summary, I think LLMs as sort of world models based on the experience of humanity as a whole are fundamentally changing AI and our world. And most of us still underestimate how much. However, we should not be fooled into thinking that these models have any sort of understanding, intelligence, or whatever, right? They are noisy statistical world model, which is a huge thing, but not more than that. And if you think they're more than that, we're going to get harmed. And that's the final slide I always show when I talk about the dangers of AI, right? It's something I like to talk about, to tell my children. With great power comes great responsibility. And that's the point. AI is a hugely consequential and powerful technology, which we have to do with responsibility. And also, that responsibility includes not just taking the easy way and saying we don't use it, because it can do good. It really is about using it and using it responsibly. Thank you.